An ideal gas undergoes a process from state 1 to state 2. The temperature and pressure of state 1 and 2 both are given. The specific heats of the ideal gas are Cp is 1 kilojoule per kg Kelvin and specific heat at constant volume is 0.7 kilojoule per kg Kelvin. The change in specific entropy of the ideal gas from state 1 to state 2 in kilojoule per kg Kelvin is, so we need to find the change in entropy corrected to 2 decimal places. Now suppose this is the TP, that is temperature pressure diagram of the process mentioned here. Okay, so from state 1 to state 2, the value of temperature, that is T1 and T2 and P1 and P2 both are given here. Okay, in this problem it's given. So the change in entropy for an ideal gas is given by delta S is equal to, from here this is going from process 1 to 2, right? So we will write here S2 minus S1. So this is equal to heat capacity at constant pressure, specific heat capacity at constant pressure, into ln T2 by T1 minus R ln P2 by P1. This is the expression of change of entropy for an ideal gas. Okay. Now in this problem we need to find first the value of R. So R is the gas constant. R is equal to Cp minus Cv. Okay. So in the problem Cp value is given as 1 kilojoule per kg Kelvin minus Cv, that is 0.7 kilojoule per kg Kelvin. So R will be equal to 0.3 kilojoule per kg Kelvin. Okay. Now let's substitute all the values in this equation and calculate the change in entropy. So delta S will be equal to Cp, that is 1 ln T2, in the problem it's given 600 Kelvin, and T1 is 300 Kelvin, minus R, that is 0.3, just calculated, into ln P2, in the problem it's given 500, and P1 is 100 kilopascal. Okay, so from here we can write delta S is equal to ln 2 minus 0.3 times of ln 5. Okay. Finally, we can write the change in specific entropy will be equal to 0.21 kilojoule per kg Kelvin. Okay, so this is our final answer. Now let's go back to the problem. The change in specific entropy of the ideal gas from state 1 to state 2 is 0.21 kilojoule per kg Kelvin, and this is rounded off to 2 decimal places. If you know this formula, you can directly substitute the values and you can get the answer. To get more information on change in entropy, you can refer to the NPTEL course lecture number 3, Concept of Entropy and Entropy Generation, by Professor Deepankar and Basu of the Department of Mechanical Engineering at IIT Guwahati.